Now that we have the introduction, let's actually get into solving. So we're going to practice solving linear inequalities in one variable. So an inequality is really, a linear inequality is really the same thing as a linear equation, except for you have a less than, greater than, less than or equal to, or greater than or equal to sign as part of it. So what you do is you're going to use all your same rules to solve as you use for solving equations, except for one change. And that is that when you multiply or divide by a negative number, you have to flip the direction of the inequality symbol. And the reason we do that is as follows. So let me just show you an example. For instance, something like 2 is less than 3 is obviously true, right? If I multiply it by a positive number, let's say I multiply it by 5, 3 times 5, then I get 10 and 15. And still 10 is less than 15. So by multiplying it by a positive, I haven't changed the direction of the inequality. It still makes sense. When you multiply it by negative though, so notice when I multiply it by -5, I get -10 and -15, but -10 is bigger than -15, right? Because -15 is further down the number line, it's more negative. So to make this still be true, I have to flip that sign. So that's what's going on here. When you multiply or when you divide by negative, it just messes it up. So to make it still be true, you have to flip the inequality sign. So that's the change to watch out for. Otherwise, we solve the same way. So for this one here, I'm just going to solve, I want to get the 3 to the other side. So I have -2x is less than or equal to 8. And then I'm going to divide by -2. And notice here, I'm specifically dividing by a negative. So I don't care if the negative is on top, I care if it's on the bottom. So I'm dividing by that negative. So I'm still going to get the same numbers, but I'm going to flip that direction. Okay, so that's going to be my answer here. And it does also want us to graph. So I'm going to graph this. I'm here at -4. Now I want x is greater than or equal to -4. So I'm going bigger than -4. So I'm starting at the -4. I'm going towards the positives. I have a equal sign here, so I'm going to use a bracket. Now you want to note here that the shaded area is your solution set. So all these values should make the equation true. So if you're not sure you shaded in the right direction, pick one of the values and plug it in. So for instance, 0 is shaded in. That means that 0 should be a solution. If I plug in 0 here, I get 3 is less than or equal to 11, which is true. So anything shaded in should make that equation true. And that's just a nice kind of quick check to make sure you've shaded the right way if you're not sure. So notice that for inequalities, we don't usually have just one answer. You actually have a range of values. We have a solution set. So any number -4 or bigger is going to make this equation true. All right, let's do another one. So same thing here, but I'm just going to solve. So I'm going to bring my x's to the left first. -3x minus 4 is greater than 5. I'm going to add 4 to both sides. And I'm going to divide by -3. Now here again, I happen to divide by a negative. So I'm going to make sure I flip that sign. So I have x is less than -3 for my answer. Notice that subtraction doesn't matter, addition doesn't matter. It's only if you multiply or divide by a negative. I do want to go ahead and graph this. So let's see, I have 0, 1, 1, 2, -3, -4. Now I want x is less than -3. I'm just reading that example here. So I am shading less than, so I'm going to the left. There is no equal sign, so I'm using a parentheses. And remember that if you want to check, you can always plug in any of these values to make sure it is true. So if you plug in -4 back at the beginning, for instance, you should get a true statement there. And I'll let you guys try that at home. If I were to plug in something like 0 that's not shaded, I would get a false statement. Okay, so anything shaded should be true. It is a solution. Anything not shaded should be false. It is not a solution. Okay, now here we have a fraction, and that's perfectly fine. We can still work with fractions like we did before. So what I would do here is I would find my common denominator, which is going to be 12, and I'm going to multiply everything by 12. Now, do note that I don't have any x's in the denominator. They're just regular fractions, so I don't need to worry about extraneous solutions here. It's still always good to check our work, but as long as you don't have any variables in the denominator, then it's just a regular problem. Notice I multiply by positive 12, so I don't have to change the sign of the inequality. Here, 12 divided by 4 is 3. 12 divided by 3 is 4. And 12 divided by 4 is 3. So now I'm going to go ahead and I'm going to multiply whatever is left over. Once you have your division, you're going to distribute or multiply through whatever is left. So let's see, here I'm going to have 3x plus 9 is greater than or equal to 4x minus 8. And then 3 times 1 is just 3. I'm going to keep simplifying here. So I have 4x minus 5. And then I'm going to keep solving. So I'm going to bring my x's to the right this time. I have 9 is greater than or equal to x minus 5. I'm going to add 5 to both sides. And I have x is less than or equal to 14 here. Now, sometimes when your x is on the right, it makes it a little bit harder to graph. So what this says is that 14 is bigger than x, or bigger than or equal to x here. So what you can do if you want, I didn't have to flip any signs here, but if you find it confusing to have your x's on the right, just always bring them to the left. Or you can always change it at the end, just make sure everything is the same, meaning that the small end goes with the x and the big open end goes with the 14. It usually is easier to graph when your x is on the left because your inequality sign will point to how you're shading. So that's a nice little trick if you're having trouble there. Okay, so here I want x is less than or equal to 14, so I'm going to shade this way. And then because I have an equality symbol, I'm going to go ahead and use a bracket. All right, now let's do these last two. And these last two I put in one problem because they do come out to be a little bit different, we'll say. So they look a little bit kind of funny. So here for the first one, I'm just going to start the same way. So I have 2x plus 8 and 2x plus 3. And then when I try to get all my variables together, I get that canceling on both sides. And I know we've seen this before, right? When our variables cancel out, just like we did with regular linear equations. So we have the same sort of idea here. And you're going to look for true or false. Now, 8 is greater than 3. This is true. So this is basically like that identity idea that we had for equations. So because our statement is true here, all real numbers are solutions. Okay. So you can write it like this in interval notation from negative infinity to infinity. You can write it like this, x such that x is a real number. Or you can write it like this. So this symbol here means the real number set. So it means that all real numbers are included here. Now, when I do this one and I try to get my x's together, again, you're going to get that canceling on both sides. But notice how here 7 is less than or equal to negative 2. That is false. So if you think back to what we did for equations, when we had a false statement, we had no solution here. So there is nothing in this case that's going to make it work. So no solution, or we can use that symbol, which was the null set. So you can get those kind of weird answers for inequalities, just like we did before with equations, and you have similar answers there as well. Those kind of similar results that we saw before. I want to do one more here with basic inequalities in this video. So this is an example of a compound inequality, and there's actually different kinds of compound inequalities. There's and compounds, and there's also or compound inequalities. So what we're doing just in our class right now is focusing on a kind of and compound inequality. So now notice here we have two inequalities. Negative 3 is less than 2x plus 1, and 2x plus 1 is less than or equal to 3. This is a compound inequality. And I also want you to note something else that's special about it, is that 2x plus 1 repeats. So this is a very specific kind of compound inequality where you have the word and you also have the same expression repeating. So what we can do is we can rewrite it as one expression instead, or what kind of like giant inequality. So you put that 2x plus 1, and then on the left side, you have that piece here. And on the right side, you have this piece. So we kind of sandwiched it together. And when we have inequalities of this style, we just isolate the x in the middle. So you kind of solve outward. So here, now you don't have to, but sometimes I just like to put like little lines here just to help me stay organized. So I'm going to start first with the 1. I want to get rid of that 1. So I would subtract it. But instead of just bringing it to one side, you do both sides at the same time. So I'm going to have 2x is less than or equal to 2. And then on this side, I'll have -4 is less than on that side. Now I keep solving. So if I want to get the x by itself, I would divide by 2. But again, I'm going to do it to all sides at the same time. So I get x is less than or equal to 1. And then on this side, it's going to be -2 is less than x. Now x is by itself. So this is our final answer here. And we can graph that. And when you graph it, you're just going to graph in between those values. So we're going to go from -2 to 1. It's like a little sandwich. And then on this side, I have a parenthesis. And here, because I have that equal sign, I'm going to use a bracket. So there's my set answer. This is my graphing answer. I know you didn't have to, but in interval notation, we could write it like this, right? Just following the same part as our graph. So you can use any of the notations here to write your answer. Just make sure as you're reading through homework and questions on exams and things that you note if they ask for a specific kind of notation. And just same thing on the other ones here real quick as well. So, you know, if you can always go from your set notation or your graph back to interval notation. So for instance, here, we're going up to 14, and then we're going down to -infinity. So I always just follow the graph. I do left to right. So it goes to -infinity, and infinities get parentheses up to 14 with a bracket. Over here, again, we're going down to -infinity, and we're going up to -3, and it had a parenthesis. And for this last one, again, just kind of going back and showing you the previous examples. Here we're starting at -4, and it had a bracket, and we're going to +infinity. So our interval notation looks like this. It's always smallest to largest. And if you have that graph, it makes it really easy because you can really just kind of copy that graph down into that interval notation. Oh, one last thing to note too before I forget. If you do actually divide by a negative here, you would still flip your inequality symbols. You would flip both of them. So here we divided by a positive, so it was an issue. But if you divide by a negative, you're still going to follow that same procedure.